Hi everyone, this is Mrs. Kovacs. I'm here to talk about linear graphs and how we can write the equation for a linear graph in the form y equals mx plus b. Just like in the last video, we're going to be talking about slope, which is represented by m, and a y-intercept, which is represented by b. It can be helpful to know how to write the equation of a line because it can help you make predictions. So for example, let's say that we're looking at this graph here and we know that we are measuring someone's money as they spend it each week. So we might have money in dollars versus the weeks that are passing. And so as you can see here, at week 0, they had $100. And after 1 week, they might have $78. After 2 weeks, they'd have $56. So for the power of an equation would be to be able to predict, say, in week 4 or in week 5, how much money is this person going to have? It's going to help us make calculations like that. Some other questions that we'll need to answer as we write the equation are, how much money did this person start with, and how much are they spending each week? That's going to be related to the y-intercept and the slope. Let's start with slope. So when I'm looking at the graph, what we want to do is first create a slope triangle, and that is going to tell us our rise over run. It doesn't matter which 2 points we use. I'm going to use these two. So we see that we're going down by some amount, so we know it'll be negative. And we're going over by 1. I know that it's by 1. When we look down, we can see that each box is going to represent a distance of 1. So when I'm looking at, I'm going to actually write this using our delta symbols. We have the change in y divided by the change in x. And then we are going to see how much is y changing by. So sometimes you can use the boxes to count, but in this case it's a little tricky because each box represents 10, and notice how this second point isn't really on a clear, what we call a lattice point. It's not really at like one of these nice corners like some of the other points might be. So what we want to do is look at the numbers. We can see that we are going from 78 to 56. So I can actually represent that using a subtraction to find the distance. And we know that we're going over by 1 for x. So that's going to be negative 22 over 1, or just negative 22. If you think back about the situation I was talking about, this might mean that the person is losing $22 each week. The next thing we want to find is our y-intercept. If you remember, that's where we intersect with our y-axis right over here. So we're going to look here and see that on the y-axis, we meet up with the red line at 100. So our y-intercept, we can say, is 0, 100. That gives us all the information we need to write our equation. Y equals mx plus b. Remember, we'll start with our slope, and the second number b is going to be for our y-intercept. Our slope was negative 22. And our y-intercept was 100. And that gives us our equation. This equation is great because, like I said, it could allow you to calculate future costs without having to continue a pattern. So for example, let's say I wanted to know in 6 weeks, how much is this person going to be in debt, right? We can see that our x-axis represented the number of weeks. And then I'm going to be able to calculate after 6 weeks, how much did this person owe, right? You'll see that we're below the axis. So negative 22 times 6 is going to be negative 132 plus 100, which means that he is negative $32 in debt after 6 weeks. So that can be the power of being able to write an equation when you're looking at a graph. Let's go ahead and take a look at some more examples. So in this example, we're dealing with slightly smaller numbers. This is more like some of the graphs you might see in Algebra 1, where the numbers are smaller and you can actually use the boxes to help you figure out what you need to find. So let's start with our slope. To find the slope, remember that we need to connect 2 points. I'm going to choose points that are like this one. Notice how they're on what we call a lattice point. They're right at the corner. I can see precisely that this is at the point -2, 3. That's going to be helpful for finding my slope. We don't want to make any guesses. So for example, if I chose this point, I might be able to say that that's halfway between 3 and 4, but I'm not sure. And so we want to actually not use that point. We want to use a different point. For example, over here, because again, I can see exactly that we're lined up with -4 and 2. So if I look at these 2 points, we can see that we are going to get from one point to the other. We're going down by 1 and then left by 2. So in this case, I actually chose 2 negative numbers because we're going down and left. It would be the same thing if you wanted to show it in the positive direction. So I can show that over here. For example, if you started at 0, 4, we could go up by 1 and right by 2. It doesn't matter which points you use because both of them will give you the same ratio. Negative divided by a negative is positive, which gives us our slope of 1/2. It's bothering me that that wasn't a perfect box, but we're just going to be okay with it. No, we're not. I'm going to try again. There we go. Next, we want to look for our y-intercept. So remember, we're going to look for where does our line cross with this line right here, the y-axis. I can see that that's happening at 4. So our y-intercept is 0, 4. We're going to take the 4 from that for our equation. And now we're ready to write our equation. Y equals mx plus b. We're going to fill in our slope and our y-intercept. So remember, our slope was 1/2. And in this case, our y-intercept was 4. A few things to keep in mind. One is to be careful with your positives and negatives. One easy trick to use is that because when we look at this line, as we start on the left and follow the line, you can see that we're increasing, going up, and that means that we're going to have a positive slope. Right? So if you ever get confused about the negatives, at the end of the day, just make sure that if your line is increasing, you have a positive slope. If it was decreasing, that would mean a negative slope. The other thing I see is for the y-intercept, make sure that you're finding the y-intercept, not the x-intercept. That wasn't really an issue in this particular graph because we don't even see where it hits our x-axis. Just make sure you're always looking at, again, the vertical axis to see where the line meets. The last part is when you're writing your equation, always remember to include both x and y. That's important, just like we kind of showed in the last problem, how you can use the equation to calculate different values for x and y. And so you want to make sure that when you're writing the equation that you actually include those. Those are what make it a helpful equation. All right, so we're going to do one last example. So this is going to be -2x plus 7. In this case, rather than looking at the graph and writing the equation, we're actually going to look at the equation and then create the graph. So it's asking us to graph y equals -2x plus 7. We're also going to compare how it would be different from these two other equations. The first thing we want to do is identify the slope and the y-intercept. To do that, I'm going to rewrite it a little bit bigger. So we can see that our slope is going to be that number before x, -2, and our y-intercept is going to be that last number, the constant, or the number without a variable, plus 7. So when you're graphing, I always like to start with the y-intercept because that's a point that you start with the y-intercept because that's a point that you know is going to be on your graph. So I'm going to go to my y-axis and I'm going to plot the point 0, 7 right here. From here, this is where you have to be a little bit more creative about your thinking. We need to force there to be a slope of -2. So remember that slope is a ratio. So there's a few different ways that you can create -2. You could go down 2 and over by 1, right? Down 2 and right by 1. There's other ways to represent that though. So for example, you could also go up by 2 and left by 1, and that would actually represent the same slope. If you want, you could even choose bigger numbers. -4 over 2 is going to be the same as -2. It's the same ratio. So then you could go down by 4 and right by 2. I'm going to show you all of these. So if I start from 7, I'll start from the point I know is on my graph. I can go down by 2 and right by 1. That's one option. And that will give me a point. Another option that we talked about was going up by 2 and left by 1. Notice how that allows me, I'm still continuing that same pattern of this line, this decreasing line. It's just a different way to think about the slope. Finally, if we wanted to think about our slope ratio in a different way, I'm going to plot this point here. We could start from our y-intercept and go down by 4 and right by 2. Because remember, -4 divided by 2 is still the same ratio of -2. So whichever one of those makes the most sense to you, you can use. I'm going to show this one here. This is usually the one that we use. Mathematicians like going right by 1 to represent our slope. And we'll connect those all into a line. So just to summarize, we started by plotting the y-intercept. Then we looked at slope ratios. A ratio is just like a fraction, which hopefully you saw by now. So then we looked at slope ratios, and then we used the slope to find the next point. Right, and remember that came from our y-intercept. That's where we started from. All right, so those are just the 3 examples we're going to go over today. I did want to go over a few things to remember. So as with most linear equations, we are starting from this basic equation y equals mx plus b, which represents the slope times x plus the value of the y-intercept. To find the slope, we used what we call a slope triangle to connect 2 points. And we looked for the vertical change, the change in y, and compared that with the horizontal change, the change in x. Oftentimes you'll hear us talk about rise divided by run. Those are more like Englishy terms that you can use instead of thinking about this fancy delta y over delta x. It just means how much we rise or go up or down. And then run, like if you're going for a run, you're usually traveling horizontally. So how much do we go up divided how much did we go over? And then that second piece that we were looking at was the y-intercept. And remember, the y-intercept is where the line crosses the y-axis. All right, thanks for listening. Bye. Hi there, I just realized I forgot to go over how our graph y equals -2x plus 7 is different from these other graphs. Silly me. Okay, so let's talk about that. Notice how for our first equation, y equals -1/2 x plus 7, what's really different is the slope. So instead of a slope ratio of -2, this graph would have a slope ratio of -1/2. So instead of going down by 2 and over by 1, we'd have a less steep line. We'd be going down by 1 and right by 2. So it would be less steep. The second equation we were given was y equals positive 2x plus 7. Once again, the difference here is our slope. In this case, our slope is positive. So with a positive slope, remember that means that we're going to end up with an increasing line. In this case, we'd be going right by 1 and up by 2. So this would be in a different direction. As you read the graph from left to right, the line would be increasing.